Good morning, all. I am Anup. So I welcome you to this webinar on advanced FEA for product development, and that is what we are offering: desktop to cloud solution. So I will once again welcome you all for this webinar, where you will see how SolidWorks and 3D experience collaboration helps you, is going to help you to make your designs from better to best through various simulation tools what we have in Simulia. So we are going to start this presentation now. So I will be taking you through this Simulia, what is the which is powered by Abaqus, and my colleague Mr. Praveen will take you through the 3D experience platform. So all of you can see my screen here. You want to have a full screen, you can click on this button, and if you want any questions to be raised, you can just type it here in the chat box, and we can address you at the end of the session. To begin with, this is in brief about the agenda, what we are going to cover. This is 3D experience. First we'll start with the 3D experience cloud platform. Then we are going to move to Simulia, which is a trusted technology in case of any of analysis what we are going to do on our products, right from the beginning stage to till the product is released. So this is the agenda what we are going to cover in this 1 hour session. So let me call up Mr. Praveen Rao, who is taking care of complete the 3D experience platform. He's heading the team. So let us welcome Praveen Rao for addressing you on 3D experience platform.
Thank you, Anup. Good morning, all, and a warm welcome to this webinar where we are going to see some new technology and new way ahead in terms of future product development, design, and all these engineering in terms of working with the 3D experience platform. What is 3D experience platform? It's a collaboration of all your activities in terms of collaboration, social collaboration, as well as 3D modeling, as well as information intelligence, and then simulation apps. What is 3D experience platform? So look, next slide, please. So what is 3D experience platform? A business experience platform providing software solutions. We have heard about SaaS, PaaS, MaaS, that is software as a service, project as a service, engineering as a service. So this is 3D experience platform is one new technology where it is on cloud, and which differs from on premises or on desktop, which gives me enormous solutions in terms of engineering, marketing, and procurement. Brings people ideas, data, and solutions in a single place. It's like platform is nothing but like your Android and iOS, where I have a phone, I have a Android, and above that I have lot many apps which is useful for me, so that I need not to procure, I need not to have anything and everything which is there in the market. I have only what I need. So the platform is providing me the access to those applications which I'm going to use on a daily basis. So this is what 3D experience platform is. It's a complete cloud platform. So social collaboration marketplace. So terminologies here, the simplification on a few terminologies which I would like to introduce to you is on premises it is operating system, but 3D experience terminology is web browser, because I do using 3D experience technology, it is machine independent, where it gives me the flexibility and seamless integration with any devices. We just need to have a web browser. There is no hardware on premises. We have to have hardware and software infrastructure, but here in the 3D experience terminology, it's just a platform like my Android or iOS. And on premises we have the terminology of licensing, but in 3D experience platform it is all roles. For example, I have the 3D experience platform with me, and I'm into only design. I can work with only designer roles, or if I'm just a business analyst, I can work with the role of business analyst, where once I get that role, I will get the relevant apps already added into those roles, so that I can have my work done very easily with the seamless collaboration. And then on-premises terminology, we talk about software products and add-on, but in 3D experience terminology, it is applications. On-premises login ID is required. Here we have in 3D experience terminology, it is like 3D passport. That's the user login credentials, which is what we use for any of the cloud applications like Facebook or LinkedIn or Netflix or whatsoever. So it's a user based, it's a role based. And on premises we would be having workstation, server, and storage, all those things in on premises. But 3D experience, it is on cloud, public cloud. This cloud is hosted by AWS, that is Amazon Web Services, and it is completely secured. And more information about that is you're going to see in the future further slides of our webinar, which is done by Anup. So going next, and for the data storage in on premise technology terminology, we call it as vault, PDM vault or vault, which is a repository of all my data on the database servers. But in 3D experience terminology, it is called a tenant. So tenant is one portion of data cloud which you have in the which you can store, where you can store your data, and you can also manage your data seamlessly. So going further, 3D experience is basically into distributed into 4 different zones in terms of usage, usage of that in engineering and manufacturing and whatsoever. So here the major portfolios, are the major differences or the distribution is among design, where we have to start with the design, and design comprises of a lot of things like drafting, sheet metal assemblies, product design, everything, so that we have the relevant apps for the design in terms of drafter, 3D creator, that is design, which helps me in creating the solid models online, that is on the browser. And 3D sculptor is nothing but X shape, which helps me in, or which gives me the flexibility of creating the surfaces on the web browser. I need not to have any applications installed onto to work on these things, which is where I just log into my tenant or log into my 3D experience platform with the user credentials, and I just use that app 3D sculptor, and I'll get the UI on the browser itself, and I create the designs, and I can store it in my 3D drive or 3D space, which is being provided by the tenant. So and these are some more major important things, but otherwise we have a lot of apps which is there in design, which we are going to see later. Then comes governance, where we have to do the project planning, change management, we have to do the architecture of the product, and then we have to release that. So there are different stages of development, where it starts from design, and it has to go through a lot of things like simulation, documentation, and then reviews, approvals, projects, and all those things. So those things can be done with a governance portfolio, where we have the brand called Innovia. Innovia is what we call for the governance solutions on 3D experience portfolio. And then when it comes to simulation, which is what we are going to see today in detail, that is SIMULIA. SIMULIA is a flagship of Dassault Systems. Again, it was there on premises, it is still there on premises, and it is also been now on cloud, where you have different applications based on the work to be done, like mechanics, structural simulation, simulation collaboration, and flow. All those things, all those applications are available on cloud based on the requirement, so that we can use those applications, and we can do our simulation work done very smooth, very fast, and again on the cloud. So next portfolio is manufacturing. That is Delmia. You must be aware of that. Delmia is also a flagship of Dassault Systems, which is and was there on premises. Now it is also on cloud. So basically these four: design, governance, simulation, and manufacturing are the portfolios of 3D experience, where we get enormous roles and relevant apps available. And all these things would be sitting on collaborative business innovator and collaborative industry innovator. These are the base of the platform. So what you see in the bottom horizontal lines, that is collaborative business innovator, collaborative industry innovators, are the base. Based on that, my roles differ. If I am only in design, I have the design roles and design applications. If I'm working on governance, I have the applications pertaining to Innovia. If I am into simulation, I will be having apps relevant to Simulia, and so as in manufacturing, it is relevant to manufacturing Delmia. So this is the basic architecture of 3D experience. So basically the division is like this. All we all know that SolidWorks was pioneer in the market in terms of desktop applications, providing solutions to the engineering industry in terms of 3D CAD simulation, flow simulation, manage and product data management, electrical PCB visualization, and so on. Same way, everything is available in terms of cloud solutions, which is what based on collaborative business innovator, collaborative industry innovator, and then design apps, Simulia, Innovia, and Delmia. So this is the broad classification of desktop solutions and also cloud solutions. Now we are going to see today is about Simulia. We have one more upcoming webinar for Innovia in the afternoon. I hope many of you have got the invitation. If not, you can touch base with us. We will send you the invitation and you can attend the webinar on Innovia as well, which is covering the governance part of portfolio and 3D experience applications. Now in this particular session, in another 30 to 40 minutes, we are going to look at how Simulia, the cloud solution, is going to help us in terms of simulation, in terms of evolving needs like physical capabilities, resources, access and flexibility, ease of use, and all those things. How easy is going to be, or how productive it is going to be using the cloud solutions of Simulia for our simulation requirements, which is what my colleague Anup is taking you through. And I'll come back to you if you have any questions in the end of the session. Stay tuned and enjoy the webinar. Over to Anup. Thank you.
Thank you, sir. Thank you. Okay. So one of the need of at present, what you're seeing right now, there are a lot of say people they are working from home, and you have seen that like vaccines also now has to be developed very fast due to this COVID-19. So this has urged us to you can say use the computer resources or for designing resources as faster as possible, and work in a remote area, from the remote area, and share our data from one person to another. So this is actually need at the present here. So and it will involve a lot of complex and physics solving also. So the 3D experience, as explained by my colleague Mr. Praveen, so this is a one-stop solution what we are going to offer you here. So it includes the Simulia technology. As you know, Simulia is a brand of Dassault system, which is known for giving realistic simulation results. So this is basically as you can see in the slide itself, this is a very pioneer and very well-known solver for nonlinear and multiphysics. And this 3D experience platform, it gives a very good support for the designers to compute the whatever the solving he is doing, analysis work is doing on the cloud. So that saves a lot of amount of his worry for investing in the infrastructure for running the analysis. And it comes with a subscription model, and we have an integrated flow workflow, what we are going to see now, like how we can develop the models inside the SolidWorks itself, or you can take it directly in the 3D experience also. But how we are going to integrate completely the models or designs from desktop to cloud. So that we are going to see. And as Praveen was explaining, so it was easy. The collaborations is very helpful through the various apps also. So we'll also get introduced to some of them, which will going to help you in day-to-day work. So basically, as I say already explained to, like Similia is a trusted technology, and basically it is a finite element software what we are using for solving the multiphysics as well as very complex nonlinear exam the analysis works also. And why this cloud computing is very helpful right now, so that we're going to study now. So basically the Similia is governed by the Abaqus. It is powered by Abaqus solver, and it is known for the high-end solution which is required for complete analysis of non-linear problems, which includes various types of non-linearity. And it is also very good in solving the implicit and explicit analysis on your products also, which require to perform dynamic vibrations to understand and predict the failure of your products when you are using in the real-time condition. So that is a brief introduction about this Similia. So this is basically what we have, what we offer to you is the Similia. It comes in 3 different roles. One is structural designer, structural performance engineer, and structural mechanical engineer roles. So basically, you are going to get a complete solution depending upon requirement. So this is different roles. They are segregated. Like, as most of you are SOLIDWORKS users, you understand, like we also have a different segregation of the capabilities based upon the different verticals. Here also based upon the different verticals requirement. So they have the Similia or the 3D experience has come up with a solution which is segregated as structure designer and performance engineer and mechanical engineer. So basically we are going to create the models, or we can design the models inside the SOLIDWORKS. As you are already having a SOLIDWORKS, we can directly just on a button you can load or upload those data in the cloud, and you can perform the analysis also. So how the data import happens when in case of any of a simulation connector, you can consider, which you can already, if a SOLIDWORKS user is there, so you can use it for loading this data from the desktop to the cloud. So basically in various CAD imports, directly you can do it, you can import it. We can add out the mesh creations, boundary conditions, and finally we are going to solve it and post processing. So this is direct import. Also we can do it inside the Similia, or if you're having a SOLIDWORKS simulation with you already available, and you require to you want little bit higher end of solutions, which is rated to hyper elastic models, you want to analyze them, so you can take help of this Similia, where it will help you to directly import all these data, like material, what is the mesh data, boundary conditions, whatever you applied in the present model itself. So it will take out, only you can directly run that analysis and see the results. So it saves a lot of amount of time in replicating the same setup once again. So it is easy to use and very automatic in model transferring. And not only that one, if you are having any model changes update, you want to do it, so that also it will run up very fast in a few clicks. So this is basically workflow what you are seeing here. So this is a model which is having a simulation. Suppose you have already set up and you have assigned all the material properties, boundary conditions here. You'll get options where you can just click on the button here. This is one tab you are going to get it. This is simulation connector. Once you click on that one, it will be uploaded to the cloud, what you are observing here, and finally you can run there itself. So it is seamlessly collaborates with SOLIDWORKS with the Similia, can be achieved just by a simple click on a button. So before going for the further part of the webinar, I want to just introduce you like what are the different roles and what are its capabilities which you can utilize for your analysis work also. So we have begin with the structural designer role. So this is also a cloud-based solution which is offered by 3D Experience platform. It is basically meant for performing any of the linear static analysis. You want to find out the natural frequency, or you want to do the modal analysis, buckling analysis, or steady state thermal analysis, you can easily use this role. It comes with various types of applications what you're seeing, which will be helpful for the editing or converting from one format to another format. Like we have a converter to IGS, so collaboration, you want to see that one for one revision cycle to another revision cycle. So all these applications what Praveen sir has explained earlier, so you can easily include them, use them for your analysis purpose. So structural performance engineer is the next level to that what we have a structural design engineer. So it includes all those capabilities what earlier the structural designer can do. Along with that one, here we can perform the nonlinear, the dynamic responses, implicit analysis you can do here. Both all the other capabilities like performing a static analysis, frequency, buckling are also included. Along with that one, you can do the implicit analysis, implicit dynamic analysis on this. So this is very good. One of the, you can say that important role which will help you to design any of your products which are dealing with vibrations related issues, and you want to design, you know that one how much time it takes to run a vibration analysis on the desktop. When you're, it might be of any type of analysis, like it's a response spectrum or random vibration, harmonic analysis. So a lot of vibration analysis, whatever you do, it takes a lot of amount of time. So this solution from the SIMULIA will help you to reduce that time. So structural mechanical engineer is the next level of what we have the solution for the structural performance engineer. So as I said, we can do all the analysis what I mentioned, like structural design engineer, structural performance engineer. You can do all these analysis. Along with that one, it is next level, you can do the explicit type of analysis, what I say random vibration. So earlier I said the earlier vibration analysis, it goes next level where you can do the high-end high-speed dynamic analysis. Many of people will come across like impact and crash analysis of different products also. When you do the drop test also, it's one form of crash analysis only that requires explicit solvers. So time required for solving this type of analysis is huge, and it takes a lot of effort also to give a proper contacts and do the proper meshing, so that you will find that okay, dynamically there will be change in the mesh when you start with the analysis and till the end. So directly it should update also. So it takes a lot of computation time also and effort also for such type of analysis. This SOLIDWORKS, this structural mechanical engineering role in SIMULIA will help you to address such challenges. So let us go through one of us, the highly nonlinear problem which we come across in day-to-day work, day-to-day also, like a clip and buckle. So it is a highly nonlinear. As you see that one, whenever you apply a load, we are going to trying to just add a clip here and inside the buckle, you are going to press it. So you see that one, it's going to slide, and it's changing, the contact is changing with respect to the time whatever the load you are applying. So such type of things, even though it looks very small component, but it involves a lot of computations to get the proper results. So let us, this is the user interface what we see inside the 3D Experience platform, where you find various types of applications, and I'm taking this example of the clip and buckle. So this is a user interface what you are seeing here inside the SIMULIA, and we are going to assign different materials, different boundary conditions here. So quickly I can go for adding the materials here. I can go for selecting the proper role here. In that role I can select any of the applications. So this is how the methodology where we are going to start the analysis. You can do structural, thermal, or both thermal and structural analysis. Then we are going to perform, we are going to add one of the boundary conditions as you are seeing here. I'm going to go for adding, taking the very good help of adding the assistants, where I'm going to just click on here, and I'm going to say that, okay, what are the setup I have to do, what are the different materials I want to assign. So this assistants will going to help me for doing that. Okay, I can select any of the method here. It can be like creating any of the type of mesh, meshing technology. We have a tetrahedron mesh is there, rule based is there. So what you ask, so most of the meshing requirement can be added here, and you can get a proper shape and sizes of your models as accurate as possible here. Defining the context is also very easy here. We have a different types of contacts like couplings or tie, which we can add up to different components. I can fix up here. I'm trying to just make sure that the boundary condition is such a way that only the translation along the z direction is kept free, and other portions it is arrested. I can give the increments also, how much increment, how you want to progress in each step of loading what you are going to do. So once you have done that one, I can just go for the meshing, the running the analysis and defining the results also. So here I have just defined the friction coefficients also, so which is very intricate when you go for. One of the greatest, you can say, saver for designer is a general contact, what we have in in the SIMULIA work, SIMULIA. So where automatically whenever the component interacts with each other, so it only detects, okay, this is a contact, and wherever it touches, even though initially it is not touching, so after touching it will indicate like, okay, this has to be a contact. So according to whatever the condition like friction coefficient I have defined, I can easily do it. So I have applied the load here. Here I'm applying the load in the form of translations about z direction with 14 millimeter of translations I'm going to apply here. So it's going to act vertically downwards. So it is a large deformation problem. So you can see that a lot of clips also will going to fade. So along the due to this large deformation, and after doing all the setting up, I can request for what are the results I'm looking for. Like I want to see the reaction forces, what are the stresses, strains, as well as the displacement in that model. And it is also possible to see step by step also. And one of the greatest things what you are seeing here, this is you can run the analysis on the cloud or on the you can say embedded also, where you can include the credits or the tokens. And you are seeing here now the results in the form of steps. You are going to get the results, and you will see that one how beautifully the SIMULIA it is going to capture the stresses as well as the strains in each step. So you can perform, you can check it with respect to the time also, or force versus force time. So one of the thing what we suggested, 3D experience platform brings us this complete option here, where I can save complete, I can share my details or my ideas to my colleagues also. If he finds like, okay, something needs to be changed, he can suggest me by going through this animations which I'm shared along with the results plot also. So very helpful and seamless in case of sharing the data, collaborating with the different users. And at the time you can also chat and discuss with your team members. You can publish those things, and he can get notifications also in if it is linked to his email. So this is how the complete collaboration also will happen in case of the model which is taken inside from the SIMULIA, and you are performing the analysis. Even the person who is not having this complete model in a desktop, he can see this as an application in the mobile also, where he can also see that one results also. That is one of the need for now, because everyone may not have the system to check on those things. He can check it in his mobile also, and he can explore what are the things, what are the models is there. this is a 3D play what you're seeing. So using that one, he can explore the complete model also. I hope you got a glimpse of like what is the complete procedure, how we the 3D experience platform with the Similia collaboration will going to happen. To continue with, let us discuss about some of the non-linearities what we address inside the Similia. So as you are aware, there are three types of non-linearity. One is geometric non-linearity, material non-linearity, and boundary type. So this is geometrical non-linearity what you are seeing. This is like a material, it's going to go into the plastic region, and this is a contact type of non-linearity what you are observing here. So all these non-linearities can be addressed inside this Similia in the different roles what I suggested earlier. So as I said, you can perform any of these analysis. So it might be one of the things like when you go for any of the analysis of your products, you might come across these one of the criteria what I'm showing now. It can be of large strain problem what you're seeing in the beam bending what is happening in the first example here, and if you're having any of a rubber isolator or any of the product which is dealing with the large deformation, so it becomes very it is very required to check how much deformation is happening so that I can make some design changes in that one. So it can be of any of the design, it can be of any of these applications. It might be suitable for your work also. It might be at hydroforming, what you're seeing, complete metal forming solutions also you can get it here. Not only that one, you are going to see that one like many people nowadays they come across the required solutions for the screws and bolts also. Bolts are the one of the criteria where they get failed and the other components get free, and it might lead to some catastrophic failure also. And in case of your mobile phones also, what you're seeing, the 3-point bending test, it is very much important to see that one how it's going to behave. And all the rubber or sleeve components what you are seeing here, you can use this the capability of nonlinear analysis to a great extent. So this is a complete workflow what you are observing here when you go for performing any of this analysis. First is suppose you are having SOLIDWORKS. So as we are moving from desktop to we are moving from the desktops to the cloud solutions. Let me take you through, like if you are having SolidWorks, from that how we are going to take out. As I said, there is a direct import what I showed in first example. Now I'm going to show you from the SolidWorks. If you're having, I want to use this capability of Similia, and I want to utilize it for complete designing work. So how it can be carried out. So basically, we are going to start this analysis from the SolidWorks itself, where I have a SolidWorks simulation with me. SolidWorks premium license is available, but I'm not able to get it complete solutions due to the model or requirement. I can take out this Similia connector here. So this will help me to share all my data. Just by click, automatically all the data will be uploaded to the 3D experience platform, and I'm going to see the I can get the results from them. So I'm just going to upload here all the details here. So you can see that one, it automatically identifies what are the setup, what is the connections, how you are defined, what are the loads here, what are the mesh. It is going to understand from the SolidWorks simulation itself just by clicking that simulation connector. I can modify the mesh. If you want to modify the mesh with a much more better way, I can delete those meshes. I can go for adding any of the mesh. Like we have a tetrahedron mesh, sweep 3D mesh, surface quad mesh is there. So all these mesh you can go for adding. We can control that how many number of elements you want to add it along the cross section. You can go for adding. So those things also very easy, and you can just go for defining any of the connections also if it required. So tie is one of the say very good option what is available in SIMULIA, so which will help you to just select the faces like what we do it in the SOLIDWORKS simulation itself. It's going to just tie those faces which are going to select, and I'm going to see that one. I'm going to just need to run this analysis. Other things whatever I have taken here, it is already taken from the SOLIDWORKS simulation itself. Finally, I can run it in the cloud. As I said, it is one of the benefit what we are going to get it, where quickly you can solve very complex and time consuming options. You can see that one in the 21 stages it has completed those analysis. And suppose what will happen if I having any of a design change, I can just switch to the SolidWorks. I will make a change here. Whatever the changes required, automatically I can make automatically can be updated. Just you will get an option here, update the geometry on the open. So when I click this one, so all the other settings whatever we had earlier will be retained along with this change model. I need to just click on once again simulate, so it will run the analysis for me, and you can going to see that one all the results are similar to like one, or the settings it can be utilized. Finally you can get the results accordingly. So it saves a lot of time and effort for us, and it is a seamless again I can say the collaboration between the SolidWorks and the 3D Experience platform. So what makes unique here again SIMULIA or Abaqus technology, it is a general contact, so it is very robust in nature. So it identifies which component is touching. So once you define the material, if I say the general contact, so you know as an engineer, suppose you have carried out a simple example also, how the contacts will going to play a part during the analysis. So it takes a lot of effort and time to define each and every contacts. We have to select the faces. It might be an edges, or it can be a complete body itself. So it takes a lot of time and effort to define all these contacts. But here in SIMULIA works, general contact automatically it determines the interactions. I may not define any of the selecting the faces also. I can say that one feature, or I can use that one to define contacts to entire assembly itself. So automatically whenever it comes across any of the components, it is going to consider it a general contact, and it is going to be a sliding contact. We can go for adding the frictions, and automatically that will reduce my work as much as possible. And as I showed you, it has a very good capability in case of meshing. So what you're observing here, I can have a very good mesh, which can be of quad mesh. We can go for adding. It can be of tetrahedral mesh, or you can go for rule based mesh also, where I'm going to rule by selecting, okay, this area should have these number of elements. We can define it accordingly. Then we can also take, by taking the outer surface or inner surface, I can take help of the continuum shell elements, or we can say octary mesh, what we call. So that also I can use it. So but one of the benefit is, again, if I define it by selecting the surfaces itself, the results it can show it in the form of 3D plot also. So this is one of the say greatest you can say capturing of the mesh, which will help you to get a proper results when you are performing a very complex analysis. So what are the various material property it can handle is, it can handle any of this plastic, hyper elastic or hyperplastic. You can go for considering them. So all these the plastics or rubber materials, it can easily work on that one. Even for metals, whatever you are having. So all these in the plastic region, it can handle with ease, and it can you can see the simultaneously how the nonlinear effects will be included while performing the analysis. And we can perform the multi-step also. So multi-step in the sense, many people ask like, okay, suppose I apply some load here, and after some time I want to apply another load. It is not like initially I'm going to apply say 100 Newton, say 20 Newton I'm going to apply load, and afterwards, after running that one, it will have some deformation. I want to apply load after it is getting deformed. So such type of loading, what we call it as a multi-step analysis, can also be carried out in SIMULIA, and it has all the capabilities which for the elements to capture, like a brick element is there, chord element is there, so they can capture beautifully how the reaction or the, you can say that, how the stresses or displacement or strains are developed in your model. Not only that one, what you're seeing here, you can perform any of the dynamic and nonlinear analysis work, so which requires a lot of computation time and effort also. You're seeing here, this is a camera model which you can drop it from certain height. So what is the impact is going to happen? So it takes a lot of time in case of in other solvers, but in Abaqus it solves very fast, and you can save up to more than 50 to 60% of your time when you're running this analysis. And not only that one, it will capture beautifully the physics of interaction of different components also, what you're observing in this one. So the prosthetic foot impact, suppose something drops on that leg, so what is going to happen with that complete model, you can easily understand. And as I said, many of us nowadays, they want to understand how the crash test is going to happen on. It may be of simple can, you can consider, or it can be of big cars also. If you want to take out, if you want to perform a crash analysis also, it can easily capture that one, and you will get a very realistic and say analysis, or you can capture beautifully the behavior of those reactions also. Now coming to this, what is a cloud-based, and what are the things we can include? I was telling you about, like, we had this topic like from desktop to cloud. So you will get some options here which you can select it, and you can decide between local and cloud computing. What you're observing here, so the local computing, in the sense you are going to take help of your desktop. Suppose you are having a workstation and you want to run that analysis in your desktop, using your desktop itself. It is also possible. You'll get an option where you can run between cloud, local and cloud, and you will get an embedded option also. So what is the benefit of running in the cloud is a person can start continue working in a SolidWorks, and the analysis, whatever the computation time will the solving is happening, it will continue in the cloud. So that is how you can increase your productivity. And it is also possible, as I said, to increase the number of cores also, in case of credits as well as the tokens. I can include them, I can buy that one. So suppose I have an urgent requirement and I am restricted with only 8 cores in my system, so it might take days of work or 2 days of run to get a solution. Instead of that one, if you go for the cloud, if you go for the tokens, you can buy for that one, and you can run that analysis. It will take out the cores accordingly as per your requirement, and it is going to consider. It is going to consider the number of 5 tokens for 1 core. So like that, it is going to consider take out the cores, and it will take out a multiple cores, more than 10 or 12 also. So it's going to consider those number of cores, and it's going to solve it. So that is the best option what we can offer you right now. It will to save the time, and it is we have this options optional available, which you can include in your analysis. And not only that one, collaboration is a very important role, very important factor in case of 3D experience platform, where I can share the data. Sharing the data is challenge right now because we are working from home. A lot of people will going to be located in different places. So sharing the data and coordinating with each other, it plays a very difficult if you are not having enough infrastructure for that. So, but this collaboration tool, whatever we have in the 3D experience platform, any of a system, you can use it for login, and you can go through the any of these analysis which is carried out. You can go through, you can run that analysis in the cloud, and we can discuss or share your comments to your colleagues also. So you'll get a secure data where you can save it, and you can work on that. Now, dealing with this Dassault system cloud security also, I was telling about, like, you'll get some space where you can save your data. So we have this SaaS available. So this is what is a simple method, what method software usually for delivering data, which you can access this data from any of the devices which is having an internet connection enabled, and it is through any of the browser you can use it. So this SaaS capability, which is going to be helpful for you for all these details, that is software as a service. Similarly, we have a platform as a service, cloud computing available. So this will help you to manage, run your any of these applications which you are going to get it along with the 3D platform, or if you are going for any of the roles of this Simulia. So you will get, you can work on them. You need not worry or on the maintaining or building of any of these applications. So you can just use it as it is and you can work on. Similarly, infrastructure as a service, this is also a form of a cloud computing. Then it is used for, again, as I said, it is virtual resources which you can use it on internet. So all these complete solutions or services, it is provided by Dassault system, and it is a highly secure one where you can use the applications, you can use the platform, and without investing much on your infrastructure on your laptops or other things. So what we offer right now is cloud computing. So we usually, as you are aware, the machine dependent, what you are doing, it requires a workstation to do any of this complex analysis work. So that we can suggest, like, we can go for the local machine for any of this CAD related work. For analysis work, we can go for the Simulia, where we can perform the analysis at any time, any place, and you can use the resources on the cloud, which by buying the credits or tokens, and you can run the analysis very faster than before. And you can get rid of this whatever we call it as a machine dependent nature what we are in right now. So I want to just tell you about something about the embedded compute and token, as well as the credit one. So what you're seeing here, so this is embedded compute, what you are doing day to day. When you're running the analysis in your system, it depends upon we usually allow around 4 cores is allowed to run it on the local system. So suppose you want to run it with the more number of cores, you have to go for the token system or credit system. So token system is nothing but you are going to get access to these number of tokens. You have to buy these tokens. So each token will execute like a single 5 tokens. If you consider, it will take a single core. So 5 tokens are required to consider it as a single core. So like that, depending upon your computation work, it will going to utilize those tokens while performing the analysis on the cloud. You'll get a credit also. Credit is like initial. Suppose you buy a SIM card, you'll get some talk time. So whenever it is not a renewable one, it is one time use what you are going to get it. So that credit you can use it also. It will, once these all runs you are doing. So if something while running your project, you come across there is a peak requirement of running the analysis faster, that time you can take help of this credit and you can utilize it. Tokens are renewable one. You can order as many as tokens as per your requirement. So these are the extra capacity. Whatever you want to include, you can include them. In case of credit consumption, what you're seeing, you can set the performance also. Like, for example, you might not require that much of very accurate solutions. In that cases, you can set it as poor condition, so where it will take out very less number of credit to compute. As you go for non-linear and dynamic explicit things, it requires the credits consumption will be more. For example, here number of credits consumes is considered as 10. For example, in case of just a linear static analysis. In case of dynamics explicit, it might consume like 100 or 1000 credits also. So depending upon your size of your model, you are going to consume the credits which are available inside in the cloud. So as the size of the model, what you're seeing, once the performance is set, the credit consumption, it will automatically, it will going to show you how much the credits are going to be consumed, also will be visible for you. So these are some of the customers who have started working on this 3D experience platform, and they are using this Simulia for extensively for their work. So Hydac is one of a customer. So they have used for the complete analysis of their existing assembly components. So where they wanted to see that one effect of the torque on their components. So they have used this SolidWorks. They have used this SolidWorks along with the Simulia. So they have achieved convergence of 100% in a reasonable time, and they have good information about the failure. As you see that one, you'll find a good distribution of the stresses or the strains what we are going to get it after the analysis. So there is, you can say, up to linear analysis or very not much complex nonlinear analysis you want to carry out in SolidWorks simulation, you can do it. If you are looking for very high-end complex analysis to be carried out, which might require a lot of computation time and the very good system, in that cases, the Simulia such as simulation engineer or performance engineer, you can use it and for solving that problem. So one more customer, they have used for microfluidic devices to investigate the behavior of a rubber. What you're seeing here under the compression, how this complete device will going to work on. So they have used it. So if you take out a comparison here, if it takes around 40 minutes to solve in the Simulia, in case of SolidWorks simulation, it might take out 21 hours. So it may not run in many cases, because it all depends upon the complexity of your models and your system. Everything is taking part in that one. So for getting that one, if you they have used Simulia, so where they have got the complete solution in just 40 minutes. So you can get now a comparison like how much time you can save while performing the analysis in case of any of these type of scenarios. So summary, what we have seen till now, we have seen that one how SolidWorks, you can say SolidWorks and 3D Experience platform with the Simulia, it will give you an accessible to integrated and associative flow, and you can also take help of SaaS as well as the platform as service options to complete for your designing work. And also, as you've seen, we can scale up from static to dynamic problems, which will require implicit and explicit analysis also. So basically, you have also gotten introduced to the SolidWorks and Simulia collaboration through the 3D Experience platform, and how easily you can share your data or the designs, and you can work on them. So this ends up with the today's session. We are open up for the questionnaires now. So we have one dedicated webinar coming up on the dynamic analysis, nonlinear and dynamic analysis on the Simulia, which we are going to focus on the vibration part. So please do attend that one also. So we are open up for the questions. I will ask Praveen also to include in this question session, so that anyone has the questions. So we'll both try to answer now itself.
Yes, very much. I'm here and glad to see there are a few questions already raised. I have one question: is Simulia valid for electrical circuit verification? That is positive or negative connection verification or short circuit area checking in electrical circuit. As of now, I don't see that kind of solution included in the cloud, but it is being evolving on a continuous basis, and I'm sure that is going to be included very shortly. I'll keep you posted on the same.
Yeah,
And
one more question is on farming. I just want to answer on that. Like it is like the people want to understand like whether we are going to use the for this similia for farming and bending one. Yes, we can easily do any of these metal forming works which will include any of a die and punch for analysis. So it is very much possible. If you are looking for that one, yes, the one of the solution for that requirement is easily addressable in Similia. Yes.
perfect. So one more question is mandatory bandwidth range information required when data handling through cloud. Also how to resolve the latency issue if occurred. To answer this question, it's all about what is the speed we require, or we suggest the speed of internet above 40 Mbps, and the latency is around 1.5, below 1.5 is what we are looking at now, and what has proven that it is going to work fine. And also I will send you the information onto your email with the details of what would be the internet infrastructure required. And one more thing, I would like to have discussion further on the new approach of FEA, and customer has given the contact details. Definitely, sir, we'll get in touch with you very shortly, and we will discuss, and also we can go into the further deep dive demonstration also as well, according to your requirement and the solutions what we carry. Thank you.
Yeah, anyone has any questions, please free to ask. So some questions arise like can we do well distortion analysis? So we want to understand a little bit more on that one, what actually you are looking for. So we want to discuss, it requires some more data for addressing. We'll call you back to understand more on that.
Anup, can you please unmute Mr. Vijay Kumar Gantimat?
Hello, Mr. Vijay. You are on.
Hi. This is Vijay from R&T Vishya, Reno compartment. My question is, we are currently using Abaqus Simulia for our current simulations. Is it required to add on this SolidWorks with providing extra usage cost, or will it be added directly to the Abaqus?
No, this platform is different. This is on cloud solution, and this is not anyway. I mean, if you have the premises on premises already, that will be there, but this is an additional one.
Okay. It mainly concentrate on the reducing the Abaqus tokens, right?
Yes.
As you explained at the end.
All these things.
Correct. Yeah.
Okay. Actually, do contact me on that said email ID, because we are regularly planning to reduce the Abaqus tokens in order to reduce the cost reduction. So that we can have one more discussion with our department or with our colleagues. If they are okay, we can have a further move.
Yeah. We would love to do that.
Definitely will.
Very shortly.
Okay. Sure.
Thank you.
Okay.
So one more question is, we can export the final model for the result. Yes, you can export it. So after the analysis, you can export that model. Yes. So anyone, if you are having any of doubts, you can ask now, or you can reach us through the emails whatever we have provided on your screen. If you want a detailed demonstration on that, on your related work, we can also do that one. Please feel free to contact us.
And to explain on licensing part of this, or the user part of this, it is both quarterly basis and yearly basis licenses are available. That is, user roles are available where you can use it for a term. It is quarterly or yearly.
So we'll wait for a couple of minutes, and we'll end the session. If you are having any questions, please do ask.
So that means since there are no questions, I would like to thank you very much for the time and attentiveness and the questions and the interest and the enthusiasm showed towards our presentation of and 3D experience solutions and particularly Simulia. Please do write to us or call us for any further information or deep dive demonstrations. We would love to do that. And thanks. Have a nice day. Stay safe. Stay healthy. Thank you very much.
Yeah, thank you very much. Okay, we are going to end this session.